Good morning. Welcome to my morning talk. Today we're going somewhere most of us only dream about, beyond Earth. But why do we even bother? What's the point of spending billions to send rockets to space? Carl Sagan wrote in Cosmos that exploration is in our nature. We began as wanderers, and we are wanderers still. A journey beyond Earth isn't escaping our planet. It's learning how to take care of it and maybe finding out we're not alone. What if I told you a Roman philosopher from 2000 years ago predicted NASA, the James Webb Telescope, and Mars missions? Let's read this together. The time will come when diligent research over long periods will bring to light things which now lie hidden. A single lifetime will not be enough. Many discoveries are reserved for ages still to come. Nature does not reveal her mysteries once and for all. Seneca, Natural Questions, 1st century. Seneca was talking about the skies, about the stars, and he said three things that describe space exploration perfectly. First, diligent research over long periods. Science takes time. Seneca knew we won't figure it all out in one lifetime. Look at space. Galileo looked up in 1609. Hubble launched in 1990. Webb in 2021. Artemis is happening now. It's 400 years of diligent research. Each generation builds the telescope the last generation dreamed of. That's exactly what Seneca meant. Point 2. Things now hidden, amazed we did not know. Seneca said our descendants will be shocked. We didn't know things so plain to them. Think about it. 50 years ago, we didn't know about exoplanets. Now, we found over 5,000 we didn't know black holes could be photographed. Now we have pictures. We thought Mars was dead. Now rovers are looking for ancient rivers. We're living proof of his prediction. Point 3. Our universe is a sorry little affair unless the universe should have something for every age to investigate. This is the most space exploration line ever. Seneca is saying, if the universe runs out of mysteries, we're done. But it doesn't. That's why we keep going. Moon, then Mars, then the outer planets, then interstellar. There is always not another question. Dark matter, dark energy, life beyond Earth. Nature does not reveal her mysteries once and for all, so neither can we stop exploring. What is space exploration? Space exploration is the use of astronomy and space technologies to explore outer space. The first historical milestone of space exploration. On October 4th, 1957, the Soviet Union launched the Earth's first artificial satellite, Sputnik 1. More than 67 years of human activity in space have produced societal benefits that improved the quality of life on Earth. The first satellite, designed to study the space environment and test initial capabilities in Earth's orbit, contributed critical knowledge and capabilities for developing satellite telecommunications, global positioning, and advanced in weather forecasting. Space exploration initiated the economic development of space today. Year after year, delivers high returns for invested funds in space. The challenges of space exploration have sparked new scientific and technological knowledge of inherent value to humankind, leading to better understanding of our universe and the solar system in which we live. Knowledge coupled with ingenuity provides people around the globe with solutions as well as useful products and services. Knowledge acquired from space exploration has also introduced new perspectives on our individual and collective place in the universe. Space exploration also results in various intangible impacts due to the social and philosophical dimensions that address the nature and meaning of human life. Intangible benefits include the enriching of culture, the inspiration of citizens, and the building of mutual understanding as a result of international cooperation among space-faring nations. These are the fundamental benefit themes: innovation, culture, and inspiration. Direct benefits. First, people are inspired. Second, scientific knowledge is generated. Third, national technical competence is improved. Fourth, innovation is transferred to new applications. Fifth, capacity and productivity of working in space are enhanced. 6. Markets for space products and services are created. 7. International space exploration partnerships are strengthened. The indirect benefits are: first, economic prosperity. Second, health. Third, environmental benefit. Fourth, safety and security. Fifth, human experience is expanded. Sixth, understanding of humankind's place in the universe is enhanced. Innovation benefits. The challenge of space exploration drives a continuing effort to design even more capable, reliable, and efficient systems requiring the utmost ingenuity. Space exploration missions use the unique capabilities of humans. Example: on-the-spot decision-making, cognitive adaptability, versatility, and robots. Example: precision, sensory, accuracy, reliability, and explainability. To achieve ambitious exploration goals, maximizing the productivity of these missions by demanding an effective partnership between human and machines drives progress in human health care, robotics, automation, and other domains. Advances in science and technology. Overcoming the challenges of working in space has led to many technological and scientific advances that have provided benefits to society on Earth, in areas including health and medicine, transportation, public safety, consumer goods, energy and environment, information technology, and industrial productivity. The wider list of technological benefits encompasses improved solar panels, implanted heart monitors, light-based anti-cancer therapy, cordless tools, lightweight, high-temperature alloys used in jet engine turbines, cameras found in today's cell phones, compact purification system, water global search and rescue system, and biomedical technologies. Global technical workforce development. Global technical workforce development investment in the Apollo moon exploration program in the 1960s correlates with the level of technical education later attained by students. Figure 3. Suggesting that the program's high public profile and dramatic achievements had a widespread influence on the level of U.S. technical education. When President John F. Kennedy stood before Congress in 1961 and said, "We were going to the moon."
Why climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
He didn't just ignite a rocket, he ignited an educational explosion. Look at this graph. The moment the Apollo program gets greenlit, the number of Americans earning PhDs in physics, engineering, and mathematics absolutely skyrockets. For a decade, the dream of space exploration turned a generation of students into literal rocket scientists. But then, December 1972 happens. Apollo 17 leaves the moon. The program ends. And almost immediately, the number crashed. When we stopped reaching for the stars, our investment in high-level science crumbled right along with it. This proves that space exploration isn't just about flag and footprints. It is a massive engine for human intellect. When you give people a grand cosmic goal, you get a smarter world. When you stop, well, the data speaks for itself. One of the lessons from Apollo is that having a visible space exploration program is important in encouraging young people to pursue science, technology, engineering, and mathematics STEM field. Such a program will also send a message to students that they have the possibility of long-term exciting careers in science and technology. The exoskeleton that helps people with disability walk again. Telemedicine. Culture and inspiration benefits. Space exploration missions offer a unique perspective on humanity's place in the universe, satisfying our curiosity and inspiring wonder. They provide the best opportunities for addressing questions such as, what is the nature of the universe? Is the identity of humankind bound to Earth? Are we and our planet unique? And is there life elsewhere in the universe? Space exploration has also inspired the development of various movies, best-selling books, songs, photographs, and paintings. Cultural products are a very visible symbol for how society relates to space exploration. These are movies that are inspired by space exploration. New means to address global challenges benefits. Space exploration is an inherently worldwide endeavor that attracts broad international interest and affects people all across the globe by producing knowledge, capabilities, and relationships that help society deal with some of the most pressing long-term global challenges. This is the photo of the Chelyabinsk asteroid. Worldwide awareness of the dangers posed by asteroids was raised by February 2013. Close approach of a 40-meter asteroid, and on the same day, the unexpected explosion over Russia of a meteor. These events triggered public concern about how to protect Earth from asteroid collisions. They also underscored the significance of the work of the International Space Group recently endorsed for creation by the United States Committee on the Peaceful Uses of Outer Space Working Group on Near-Earth Objects. Conclusion. Space exploration has produced an impressive record of benefits for humanity. Space exploration has driven scientific and technological innovations that benefits people around the globe every day. It provides unique opportunities to address some of the most global challenges facing society today. When nations work together on challenging space missions, this promotes international cooperation beyond the realm of space. It aligns interests and forges relationships that further peace and stability on Earth. Thank you for watching.